Alright, let's continue to filter rows based on a multiple condition. In the last class, we have seen that how to use a single column to filter rows, right? And that was the notebook where we were working. And let me give you a brief intro. That's the data frame that we have, and that's the data frame it's a dictionary. That's the data frame we created manually, right? It's a dictionary with opening curly and closing bracket, and that's the key we have, and we have some values there, and it's in the form of list. And we use that dictionary to use a data frame class to create an object of the data frame, and that data frame has now the columns. All right, let's run this cell again, sale data and sale data. Okay, so we use sales df as a head is a method that will print the first 5 rows in the data frame. And if you use tail method, that it will print the last 5 rows. All right, and that function, that method, that shape will give you rows by column. That means we have 8 rows and we have 7 columns. And you can also convert these rows, these names into a list as well. All right, and the important one is to look at the types, because these types are important to do the statistical analysis. Statistical analysis means that you can find the mean, median, standard deviation, 25 percentile, 50 percentile, and also 70 percentile. All right, and we can select. So I'm just giving you a brief intro, and then we'll continue to look at few more methods that are extremely important in data analysis section. All right, so we can also select one column. So that's my sale df, and we provide the name of the column. It will print the values over there. And you can also select multiple column as well, right? And this is here we were in the last class, and we now trying to filter rows. Filter rows means that we will select rows where region is equal to south, right? And that's the condition we put, and that's the comparison operator. So we are saying we want rows where region is equal to south. All right, and that could also, you can also use single quote as well. So Python is again very friendly language, and that's the mask we got. Okay, that's the mask we got, and it's saying the first row is true where region is, that's the row we have where region is south. And the fifth row, let me print all rows. So we have 8 rows here, and the fifth row here, that the region is south. That's also true. So that's the mask we created. Let me create a variable there and assign these results to this variable, and that's the mask we have. And to get those rows, we now need to pass this mask to the original data frame, right? So there, to pass this to original data frame, we have a data frame as sales df, and that's the mask we now will forward to this data frame. Okay, so now we left with these 2 rows. All right, so that's a single condition that we use, but you can also use multiple conditions, right? Multiple condition means that you have multiple columns and you want to filter rows based on some conditions. And to filter rows based on multiple conditions, we usually use logical or logical AND operations. Okay, logical OR and logical AND operations. That means that in OR, at least one condition is to be true, and in OR at least one condition is to be true, and in AND both condition is to be true. When I say both, let's assume that we have 2 variable x and y, but you can put conditions even more than 2 columns. For instance, we want to put condition where region is equal to south and product is equal to laptop and units greater equal to, let's say, 2. So these are 3 variables we have. So that means all these variable needs to be true, and then you get the results. All right, now let's continue. Let's create a variable that we want to filter products where product is equal to phone, and where units greater equal to 4. So that means both conditions needs to be true, and this is what we want. So that's we That's we have the data frame name is sales df. Okay, that's the data frame we have, and we want to filter rows. That is where product is equal to phone. All right, and okay, that's the and sign we use in Python. So let's assume you are working in another language. I think in other languages you have to use two and symbol. These two and symbol, in Python we can use only a once and symbol, and sales df and where units. Okay, that's the column name we have, units greater equal 4. Okay, that's what we want. And now it's just a mask, and the good practice is always to use these parentheses around these conditions so that we clearly differentiate the first part and the second part, and that's the second part we have here. And now that's it's a mask, and what we need is that we want to filter rows from the regional df, and the regional df, that's the regional df that should be outside. Okay, that will be outside, and we have now put a condition based on multiple conditions, and you see that we have a phone here where units are greater equal to 5. Okay, so you can save this as a new copy and to name it maybe again filter rows, and that's a new df we have now. And in case if you want to print those values, and the same thing applies. So now we have another data frame, and that's the filter data frame we have, and that would be, let's say we want to print the head. Okay, so head will print 5 rows, so we only left with 2 rows, so it will only print these 2 rows that we have. All right, now you can also create columns. You can also create more columns, okay, based on some conditions. Let's say that's the data frame we have. I will move again to the original data frame. That's the data frame we have. Okay, we haven't made any change to original data frame because whatever the condition we put, we have a new data frame there. So the original data frame is still the same. If you run that one, you will see that original data frame is still there. And now what I want to create few more columns. Okay, few more columns means that I'm going to create a new column, that's sales df, and that would be gross revenue. Okay, that will be that's the name of a new column that we are trying to create, that is gross revenue, and that will be equal to sales df. That's the column we already have there. Okay, that's the column that we already have, that we have units there. Okay, that's the unit we have here, and we're going to multiply it, that this column will be multiplied with unit price. Okay, and let me just copy this one here, and that would be unit price. Okay, so we just introduce a new column and we just multiply these columns to each other, and now we have a new column there. And now let's see now if you print out the column, you will see that the new column is there, that is gross revenue. And now let's also create a new column. Let me copy this one, and the new column name is discount amount. Okay, that is discount amount, and that will be gross revenue. Okay, that will be a gross revenue. That's the column that we just introduced, gross revenue multiply discount. Okay, and we now have a new column there. Now let me show you that again. Let me print as sales head again, and you see we have a discount amount there. And now the final column that is important, that is the net revenue. So I'm just trying to introduce new columns based on condition. That's the idea, is that once you have the data frame, you are still doing pre-processing, you're still analyzing the data, and so that we can produce more columns at the end. When we have all the analysis, we can save into a new file and also extract the information that we need. All right, and the last column we have is to have a net revenue, and that net revenue is equal to the gross revenue and the discount amount, because that's the net revenue that we have. And let me print out these values, and so that's these are the columns that we just introduced, three more columns. Okay, And sometime sometime we also need to sort data just to have a quick analysis what we have in our data frame. And sorting is similar to SQL structured query language SQL, that we have ascending order and descending order. In ascending order means that smallest values to the largest values, and the descending order means largest values to the smallest one. Okay, that's this is how we sort the data. And now we're going to sort net revenue in a descending order. So in Python we do not have a descending, so we only have an ascending order. That means we can play with true or false there. True or false means if ascending is true, then it will be lower to higher values, and if it is false, then it's from higher to lower values. Okay, now let me explain that concept. So that we have a sales df, and we're going to sort values. So that's a method sort values, and by net revenue. Okay, that's net revenue. We have a column here, net revenue. Okay, and the second argument we have is that ascending is for, because by default ascending is true. By default ascending is true. We are saying that ascending is false. Okay, and let's run this one, and you will see now you have higher values to small largest values to the smallest values. Okay, so we have net revenue. Here's the higher value we have, and then we have the smallest values here. And Python is again very friendly. You can also use head here, and just to print out maybe 3 values. Okay, so we got now left with 3 values there. Then the most important topic in data analysis, the most important one in the data analysis is to deal with the missing values. Again, we deal with the missing values, right? Because sometimes it's always true that whenever you get data, there are always missing values, and you have to deal with them. And there are different ways to deal with missing values. So that's why you remember that we have this one library numpy np, because we have to deal with not a number. That means the column where rows have empty, rows are empty, and we do not have a value there. And it's very common to have in the business data, and sometimes we have an empty blank rows, and sometimes there are just what can I say, sometimes you have just single quotes there, so these are not np-net. So first you need, so the idea is that whenever you see that the value is not making any sense, you need to convert to np-net. And then if the column is numeric, then we can play with mean and median, and maybe any other function, user defined function we can have. Or if it is an object string values, we can maybe replace with the custom values, or maybe the values which are commonly found in our data frame. Okay, so now let's create a new data frame. Let me just copy from here, and then we're going to lead with missing values. So there are different ways we will see that one. And here, now let me create a few more cells so we can differentiate that this is the missing values. Okay, so this is how we put comments in your Jupyter notebook, where this is not a markdown column, it's a code. Okay, so if you make it a mark column, then it will become a heading. Okay, so that's the data frame we have. And in this data frame, okay, so I just remember the function that we use to remove these spaces. That function name is trim. Okay, sometime because right now I'm manually removing these spaces, but let's say you have thousands of rows, you can simply use trim method, and that will remove these spaces before and after the string. Okay, so that's the data frame we have. And now let's print out the first few values, and we can see how the df looks like. So we have an empty value in this column, and we also have an empty, not a number, that's a np-net values in price column. And we also have another value. So we intentionally put these values. So how can we deal with these missing values? So different ways. One way is to drop these all rows. So if we drop these all rows, so we only left with this first one and the last one, so you will lose information here. So you will lose these two rows. Okay, so that's if we drop these rows. That is not an ideal approach, so we always have to find the best way where we can deal with these values. And one way, whenever you import or have a data frame, import meaning that you have an external file and you use a method to read those CSV files, and that will also become a data frame, right? And once you have the data frame, there is a method that can be used to confirm that do we have any missing values, or the data is that is already pre-processed, and that is NA. Yes, right, is NA. That's the method. And this is NA is saying that's where we have nan, so that's when it is here true. Yes, it's, you see the second row, that means it's the third row because indexes start from here, third row and the second column. Okay, that's one is, it's here true and it's also here true. It's just again gives you a boolean, it's again a mask, and then you can use a sum method to count the total number of missing values in a column, right? And we have missing one in category, we have one missing value, and we have in one missing value in price, and we also have one missing value in quantity, right? Okay, now let's deal with these missing values. And to deal with missing value, instead of making changes to your original df, let's create a copy of the data frame, and that is stock, let's say stock clean. Okay, clean means that we are now trying to create a new copy, and that will be a stock df dot copy method, and we have a new copy, and that's a stock clean here. Okay, the same thing again, we just created a new copy of the data frame. We are not trying to make the changes to the original df. Okay, and now let's see, we have, okay, that's the function. So we are saying stock clean category fill na, so the fill na method is used. Okay, that's the fill na method. We're saying you have to fill this column, category column, fill na with an unknown value. Okay, the unknown string, that is mean this value is unknown, we don't know what's the name of, what was the name here. Okay, so we are saying just fill it with just an unknown. Okay, you see. And now if you print out or display the data frame, you will see unknown will be replaced there. It's not there, you have to assign this one again to that column. You're saying now you have to, when you fill this value, then assign to the same column that we have there. Okay, that's the stuff I was missing. And now it's saying unknown key, I think that's the space is again causing the problem. That's the space is here that is causing problem. Okay, and now do we have yes, the, you see now we have unknown there. Okay, once you made the changes, assign it to same column, right? That's the idea here. And so this is how we deal with string values, because dealing with string values we cannot find a mean and median there, or any other user defined functions where we can perform any statistical analysis and then we come up with a new value. So in case of string values, you have to come up with some random some string, right? Some string mean maybe you can replace this with accessories, or maybe you can replace with this display as well. So this is how you can replace string values. So in case of replacing numeric values, there are two methods which are widely used, and one is the mean and the other one is median. Okay, or maybe you can replace with even simple 0, right? And how to find the mean is how to find the mean is to sum all this value and then divided by total. And let's find the mean, and the mean is mean of this column. The column name is price, okay, and the method is mean. Okay, so you see we have mean and also we have a median there, so we are just trying to find the mean. And now once you have the mean, and that will be assigned to variable mean, and if you print that variable, you will see it's saying the price column is unknown. Do we have a space there? Yes, I think. You see, whenever you see a key error, that means the column name is not there. Okay, that's why I quickly understand that there's something is wrong with the column name. Okay, because that space will become a part of the column. That's the mistake I was doing. Let's run these cells again, and you'll see the mean is saying NP float 86.6. okay, that's the mean, and that's again float value. In case, instead of, if you confuse with this one, you can simply use the print method. So that's the mean we have. Okay, and now if we have to replace this one, we need to assign the same column. That's the column we have, and the column name is price, and we are saying that will be equal to stock price dot fill NA with the mean, because before that we were using a string there. Now we're saying you have to replace with the mean. That's the mean, we just found it, and that's the mean. And now let's print out the column again. Okay, and you will see the mean will be there. Is it there? Yes, 86.66. you see, this is how we can replace the mean. And the next one is saying that you can also replace with the constant fixed values. You see, this is replacing with 0. In case if you think the mean is not working, you can replace even with zeros or maybe any other number. Okay, so that's the idea. The fill NA method is used to deal with the missing values. All right, then okay, that's the stuff that I already have explained, that if you use stock DFA, that's mean if you drop these values, you will left with just 2 rows. This row will, you will left with this row and the third one, right? Because we are saying just simply drop wherever you find missing value, just simply drop it, and that's not an ideal approach. Okay, and the next one is grouping. Grouping is group by. It's a very important and interesting topic, because once you know how to group data, you can do a very quick analysis of your data frame and find some meaningful information from there. And I have a separate file for group by, and let me open that one. Okay, so that's the group one. All right, so why we use group by, let me make it slightly bigger. So group by used to organize data into groups based on a common value. Okay, we are trying to make groups based on a common values, right? And let me just create that data frame again, and we will see that what different aggregate functions we can use to extract information very quickly using this method group by. And let's have a data. Okay, I'm going to copy the data frame. Okay, that's the data we have, and we have few names. Okay, that's a few names we have, and these are the student names, and we don't need that one. Okay, that's the key, and that's also a key. Okay, these are the keys we have, and we have few values there. Okay, we have few names. Sorry for that. I just, instead of typing, I just copied it from the file. but the idea is very simple and straightforward, that it's a very small dictionary we have. Okay, that's a very small dictionary we have. And this dictionary has 3 columns. One is name, department, marks, and we have names: Ali, Sarah, John, and Emma, and 2 students from computer science, 1 student is from math, 2 students are from math, and they have these marks. Okay, that's the data. And now let's create a df that will be equal to pd dot data frame, and now we'll forward this dictionary data, and that's the df we have. Okay, these are now we're going to apply some aggregate functions. For instance, we like to see, let me show you an example. So that's the data frame we have. And why we use, I just told you that we can find the averages, and these are the aggregate functions we have. And then we can also quickly find the totals, and to count items, and also find the maximum and minimum values. Okay, so now we're going to apply group by on department column. Okay, that's the column we have, and we would like to see the mean values there, and we also group by. And the syntax is that we are going to df so that's a method that is group by. I'm going to use double column department, that's the name department, and the syntax, and we need the column that is marks, and we like to see the mean values. Okay, and it's saying in math we have, oh, so there's the difference. You see, I just again got confused why we got math twice here because this math we have a math that is 88.0, and there's another one. That issue again came through this space because Python thinks there's another different string, so it's very important that they match exactly. Math is equal to math, so that math was not equal to math. That was an again problem, and now we have the right output, that is CS 87.5. the average mean value is there 87.5, and for the math 83.0. so that's a quick way of finding mean, and to find the total, and also the minimum, maximum, and also group by different columns, right? And we can also find, so that's the group by similar together and perform operations on each group. And these are the other operations we have average, sum, count, maximum, and minimum. Let's look at the sum. Okay, no, and the sum is very simple and straightforward. Let's look at the max, and that's the method we have, and that the maximum in computer science is 90. Yeah, you see, that's the 90 we have, and the maximum in math is 88. Let's make this 98 and see that is it working. Yes, you see, and C is 90 and 90 in math, and we have 90. So that's the idea of group by. And another important function, another important method in data analysis is to deal with concatenation, and the second one is merging. Okay, that's we now going to see. But before that, let's look at what we have in the slide. Then we jump to a new topic, that is concatenation and merging, right? And group by, so that's we just have seen. So you can also group by using different aggregate functions on a single statement. That's we have product summary. We're saying group by products and get the aggregate of unit as sum. We need unit as sum, net revenue as sum, discount we need a mean value there. Okay, so you can apply different aggregate function on a single statement as well. And you can also group by two columns that, so that now we're using a different data frame. Let me show you the data frame we working. That's the data frame we are working, sales data. Okay, and let me print again dot head. Okay, that's sales df. We have sales df. the error you see, it's saying dictionary object has no attribute head. That was a dictionary, so that was a dictionary. Because it's a dictionary, it has no attribute head, because we have data frame that has a method head. Okay, that's the data frame we have. And that way you can also apply multiple, you can use group by on multiple columns, and that's we are saying, and that's the list of column. You see, that's the list of column, and we're saying first group by region, and then group by product, and then show the total revenue. Okay, the total revenue there. Okay, that's name sales is not defined. Okay, that's we do not have sales, we have sales df. Okay, so that's the total value. So we have east, laptop and phone, this is the total number, and for north, laptop and tablet, that's the total value. Okay, so we are grouping first region and the second is product. Okay, that's the region is outside as in the first column, and then we have product, and then we have total values for region first and then product. All right, then let's see. Okay, so you can also apply user defined functions. User defined functions mean that you have your own function and you're trying to create a column based on a condition, right? Based on a condition. So based on a condition mean that we have a net revenue. This is how we can create a functions. Function means that it will be a user defined def, and the function name is order size. Okay, that's the name of the function. Okay, it's not a method, and we going to take the net revenue column. That's the syntax. And now we are saying that if you don't need, even if you put those parentheses, it will not affect your code. Just do not, it's again your choice. Let's use them. If net revenue greater or equal 2000, then we will return what going to return large order. Okay, that's the string we're going to return, large order. You don't need semicolon. And elif, okay, that's the syntax. If net revenue greater or equal, what's the range, 1000, we're going to return medium order. Medium, is it medium there? Yes, medium order. And else, okay, that's else, otherwise we will return small order. Okay, that's a very small function we have, and that's the definition here. Okay, now we have to apply that function. You just need, where we want to apply, we want to apply it to this column, net revenue. Okay, which is, calling function is simple and straightforward. That's the function we have. Okay, that's the function we have, and we are saying we will apply order size. That's the function we have. Okay, we will apply this function, that is here, to this column. Okay, and it will be applied here. Okay, so again, sales, it's a sales df. We have a sales df. Again, it's again a mask. We have to save it to a new column. Let's say the column name is order size. Okay, we just applied that function. Now let's see the sales df, and that's sales df dot head. Okay, you will see a new column that is here. All right, and now I think we almost there. And this is how you can select multiple columns. Okay, that's we already have we already have seen that how to select multiple columns. Multiple columns mean now, let's say I just want to print the first 3 columns, or you need to provide a list of columns what you like to export. Just assume you want to export few columns, and you can provide a list of columns here to export. But I think it's at this point it's not important, because we just like to export almost all the pre-processing we have done on this data frame. And to export this file, the method is to CSV, or maybe Excel file, or maybe an HTML, or maybe a JSON. So we're going to export this one, sales df. Okay, that's the data frame. Okay, that data frame has these function, these methods. So that will be to, you see, to clipboard, to CSV, to dictionary, to Excel, to feeder, to GBP, to HDF, HTML. So these are different methods we have. So let me export it to CSV, and then we need a path where you want to export this file. So we are working inside this folder. That's the folder we are working. Okay, and if you want to export into this folder, you have to give the path like this, data. You see, that's the data we have, and then the name of the file is, let's say, export.csv. okay, index is equal to false. It's again, that's the argument is optional. Okay, index false. I'm saying that I don't need this as a column 0, 1 to 3. That's by default it's true. Okay, you will, once if you do not provide this one, there will be a CSV file, and there is an extra column which has these values 0, 1, 2 and 3. So we don't need that one. Let's export that one, and let's see, do we have that file there? So we exported this data into here. Use that's the file we have. Okay, and we have all the columns that we created. And what else? Yes, now the last topic in Pandas and df data frame is to concatenate and merge. Concatenation is simple. Concatenation means that we have a data frame, 2 data frames, and we can use stack on top of each other, right? 2 data frames to concat. And the other concept is, so you can stack on each other using rows, and otherwise you can use column based concatenation. Okay, let me give you this example, and we will see the differences. And the second concept is to merge. Merge is similar to joins in SQL, structured query language SQL. So we have inner join, outer join, left join, inner join, outer join, right, left join, right join. These are the 4 joins we have. And Pandas by default will be inner join. So we will see these few examples. But before, let's look at concatenation first. Okay, the concatenation is let's see example. So these are the 2 data frames we have. Okay, that's the data frame we have. We have January sale, and that's the pd.data frame, and inside is a dictionary. You see, that's the dictionary we have, and we have 3 columns there: month, region, and revenue. Okay, and we have just 2 values as a list. Okay, it's a very small data frame, and we are saying pd concat. Okay, that's again object of Pandas, and we need to provide the data frame names. So we are saying January sales and February sales. Okay, and they will be stacked on top of each other. And that ignored index is important. Let me show you first. I think that's, let me comment this one. Okay, and let's put this one here, and we have first. Okay, no need to remove spaces. We are not going to filter rows. Okay, these are the 2 data frames we have, and we're going to concat. Let's put that one here. Okay, and if you remove this one, ignore index true, you will see a difference. Let's see, and then use monthly sales dot head. But before that, before doing concatenation, let's first print out, let's first let me show you the data frame first. That's January sales dot head. Okay, that's the data frame, very small data frame we have. And then we have February sales dot head. These two data frames, and indexes are 0 1 0 1. And if we use this syntax without ignore index true, you will see a difference. Again, you see 0 1 0 1. Usually indexes are not 0 1 like this. They are a sequence of numbers 0 1 2 3 and 4, because now we have duplicate values for the indexes. That's not an ideal approach in case if you are filtering using iLock. It will cause a problem there. Okay, and we go iLock, yes, location based, and we going to ignore these indexes, and that is ignore index is equal to true, right? And you will see now we have a proper indexes 0 1 2 and 3, and indexes always start from 0. Okay, and then the last concept. Okay, so this is how we can do a concatenation, and then that's another concept is merging data frame. And I told you that it's very similar to SQL, structured query language, that we have 4 kind of this is similar to joins. Okay, that's similar to joins. We have inner join, left join, right join, left and inner, left, right, outer. Okay, that's the join. And why we need that, I created a very again a separate file to explain this concept, because it's again very important, and we use a lot during data analysis. We use a lot, and that file you will find on the canvas, and that file name is wait, merge. That's the one here. Okay, and now let's use these examples, and we see the differences of different kind of joints we have here. Okay, and let me make it slightly bigger. And merge, we use combine 2 data frames using a common column. Okay, this is how we merge 2 columns based on a column. And the data frames we have 2 data frame is that's the first data frame. Okay, let's create a data frame here. Okay, that's the data frame. Okay, that's not a string, because these are not the codes the Python understand. And let me remove that one. And these are also not keys. It's a very small data frame with 2 columns. Okay, and the first column name is ID, and the second column name is name. And let's df1 dot head method to print out these values. All right, and now let's create the second data frame. And the second data frame is we're going to have, let's say df2 will be equal to, we just create a column where we can merge these values. Okay, merge these values on a column, right? That's the idea of merging, right? And the other column we have is to pd, that is data frame, and that's the opening and closing parentheses. Instead of having a separate dictionary, let's put that dictionary inside. Okay, and you can also move it to next line, so these spaces again will not be any issue here. And now we have to create a column where we can put a join, and that is id, and let's say we have 1 2 and 4. Okay, so why I use 1 2, because we also have a 1 2, and when we merge, that will be inner join, and it will show you the rows where this id is common, right? That's the idea of having inner join. Okay, and the other column is let's say that the column is salary. Okay, and the salary is, let's say here 55,000, and then we have 6,000 for the second row, and let's say 5,600 for the third row. And let's print out that is df2 dot head. Okay, we have these two data frames, and we use merge, combine two tables using a common column, and the common column here is id. Okay, that's the id we going to use. And now the pd, we're going to use merge, and the pd dot merge. Okay, the pd dot merge, and we are saying df1, not the df1, merge this one df2. Okay, and on is equal to where? On id column. So we are saying this is the first data frame, df is the second data frame, and oid tells pandas to match rows using id column. Okay, that's the idea. Tells pandas to match the rows using id column, right? And you will see that we have id1 here, id1 here, id1 here. So these both values are same, and we got Alice and Bob, Alice here and Bob here, and their salary is 5,000 and the 6,000. So by default it's an inner join. Okay, and then the other one is the left join. Okay, so we are not using here another argument, that is how. Okay, that is how is equal to that. By default is inner join. Okay, the by default is inner. Okay, that's the inner, we have the same value. And in case if we use left join, okay, that's the left one, then it will, so we will have rows, all the rows from df1. Okay, and these all rows from df1 are kept. Okay, these they will be there, and the rows where we do not have value, it will be replaced with nan. Okay, so that's the one here. So we have all the rows from the left data frame, these all rows we have, and we have a nan there because we do not have a value for Charlie because its id is 4, right? And if we use right, okay, if we use right, then we have all the values from the right data frame, and for the left where we have a Charlie, we have a nan there. Okay, we have a nan there here. That's a left and right join. And the final one is the outer join. Outer join means that you merge these two data frame, and we will have nan where we do not have any common values. Okay, and that will be outer. Okay, so we have nan here and nan here. We don't have any value here, but we are saying show both left and right data frames in the on your final results. Okay, so now let's see. So this is what that's a complete guide. You can see, you will find on the canvas. Okay, basic merging. So that's on, we use on. Okay, on tells pandas to match rows using id column. And what else? We use left join. When we use left join, all rows from df1 are kept, and if no matching cell exists, pandas insert nan. Okay, so it's a nan, not a number. Okay, right join, and all rows from df2 are kept, and missing names become nan there. Okay, that's the one here. Okay, we have nan here. And in case of outer join, kept all rows from both tables, and missing values will become nan. Okay, and inner join, keep matching rows only. Okay, in this case here, inner join. just give us the values where we have a common values 1 and 2. Not a common value, it's not a common value, it's a matching values. Okay, 1 and 2 matching rows. Keep all left table rows and keep all right table rows and keep all rows from both sides in case of outer join. All right, then what else we have in data analysis? Pandas says, so these are few other functions that can be used for quick simple analysis in order to find total net revenue. It's very now simple straightforward. That's the column we have, and we need a sum, total net revenue there. That's the column you will get. And to find the average net revenue, there's a mean method. We already have seen how to use mean value, and that round is used because you see that during mean we have seen when we dealing with missing values, that's the mean. You see, we have more precision here. Usually we need just 2 numbers after the decimal point, and that round function is used. We are saying we just need 2 values after that decimal point. Okay, that's the function we have. And then we have group by. idx max will give you the position where we have the maximum value, and then we are saying find the best product and give the position of that product. All right, then okay, this is how we can export. We already have exported the files. Once you've done all the pre-processing, you at the end you have 2 directions there. The one direction is to export your CSV file, and the other direction is to visualize it. There are libraries we can visualize. Once you have all the pre-processed data, you have to visualize it and to present the audience that this is what we find. Okay, sometimes we have to visualize, sometimes we have to just to show the stats. Okay, in case of stats, that's a quick analysis. You find the stats, and in case you have a lot of rows, then you have to visualize it, because you cannot show stats in a very single small slide. All right, okay, so now we're done with Pandas, and we work with the tabular data in Pandas, and we also have seen that how to import and export CSV files. Importing is read CSV, export is to CSV. You can also import Excel, HTML, JSON, right? Head function is used to print out the first 5 values, tails the last 5 values. Shape will give rows by columns. Columns will print out the name of your CSV file. And D type helps you to inspect it, what different data types they have. And we have also seen how to do filtering, and we also sorted the data. We also deal with missing values, different ways to deal with the missing values. And we also have seen group by, concatenation, and we also have seen merge.